In this video, I'm going to introduce you to while loops. While loops are fairly similar to for loops, but they have a few key differences. So while loops involve something called a toggle. That's an important concept in programming, and so it's good that you'll learn about it here. Now, in many cases, while loops and for loops can be used to obtain the same result, but there are some circumstances where while loops are preferred, and I will show you an example of that later in the video. So the way that a while loop works is that it keeps running all of the code in between while and end. So again, this is the key word here, while. And here we have our conditional statement. This is a Boolean statement. I'm calling this variable toggle because I'm using it as a toggle. Now notice here I set it to false. So here we have the conditional statement, and here's all the code that is in between while and end. So the idea of a while statement is that all of the code gets run over and over and over and over and over and over and over again, endlessly, as long as this while toggle is set to be true. So as long as this conditional Boolean statement here is true, then this code keeps being run. And when this is false, then the code here is not run. Okay, so I'm going to run all of the code in this cell, all of these lines of code, by pressing Control-Enter on the keyboard. Now notice, nothing actually happened. It didn't print out this message. And that's because this toggle here is false. So the conditional statement here is false. So this code never actually gets run. Now, we can change this. I can set this to be true, or interestingly, I can also set this to be a tilde. So I can negate this logical statement using this tilde. You remember I introduced this tilde concept in the section on variables and the video on Boolean. So now if I run this again, you can see that this is continuously printing out. I'm working on step 1 and it makes me happy. So, I'm happy that Matlab is happy, but this is running ad infinitum. This is going on forever and ever and ever. In fact, this is never going to stop printing out this line of code until, like, I unplug the computer or the sun blows up and vaporizes the earth. So what do we do? How do we stop this? Well, if you're ever stuck inside an infinite loop like this, or maybe even not an infinite loop, but if you're stuck inside of a loop and you want to quit, you click in the command window, so you activate the command window, and then you press Control-C on the keyboard. And Control-C is MATLAB's way of forcing an operation. So this says operation terminated by the user. Okay, so I pressed Control-C, and that stopped this infinite loop. So why is this an infinite loop here? Well, this toggle is false, and then it becomes true with this tilde. So, and then it never becomes negated here. So this toggle is always true here, or this conditional statement is always true. So this line of code is always run. Now, one thing that might be interesting is to let this loop run through 10 times. Now, you already know how to, display this message 10 times using a for loop. But what I encourage you to do now is pause the video and see if you can fix this code. See if you can adjust this code so that we have 10 iterations inside this while loop, printing out this message 10 times, and then it stops while still using a while loop. So we don't want to just take the easy way and use a for loop. Okay, so one way to do this is to take advantage of this variable here, idx. Now what I'm going to do is increase this variable idx by 1 each iteration. So I'm going to say idx equals idx plus 1. Now, that's still going to give us an infinite loop, and I'm going to show you that by running this code. This is, okay, now I'm going to press Control-C. You can see it got up to 42,000 iterations. That was just in a few seconds. It already did over 40,000 iterations. So this is not sufficient. What we need to do is add some other code, some additional code, and in fact, this is going to be a nested control statement. So I'm going to say if idx is greater than 10, then set toggle to be equal to false. And actually now I'm going to, just because I just wanted to show you this, or have this format here just to remind you of the tilde, but actually it's a little bit confusing. So I'm going to set the toggle initially to be true, and then we say if idx, this variable as it's being increased, when this is greater than 10, then we set the toggle to be false. So now I can run this again. And now this is pretty interesting. It's actually, the code actually stopped. And we saw, so it starts on step 1, iteration 1, and then 2, and then 3 and 4, all the way up to 10. And then what happens here at 10, so this goes through the 10th iteration, idx equals 10. And then we run this line of code here. And then idx gets incremented to be 11. So this printed out the 10th iteration, and then we increase idx to be 11. And now this conditional is actually true. idx is greater than 10, which means the toggle was set to be false. And then the toggle is set to be false. So now the end of this if statement, then we get to the end of this while loop, and then Matlab goes back up to the top and it says, is this conditional still true? Is toggle still equal to true? And the answer now is false. So toggle is false. So now this code doesn't run anymore and we exit the while loop. So this was an example of how a while loop and a for loop can give you the same result in the end. In this particular case, I would say a for loop is better than a while loop because we have all this extra stuff that we need to worry about for the while loop that we didn't need to worry about with the for loop. Now, a for loop is better in this particular situation because we know a priori exactly how many iterations we want. And that is the key difference between, or the key discriminator for when you should use a for loop and when you should use a while loop. When you know in advance how many iterations need to be run, then you can also solve the problem using a while loop, but in general, a for loop is preferred. Now I want to show you an example where a while loop is going to be preferred. So what we are doing here is setting up a while loop. You can see we start with the toggle set to be true, and then we have this variable called curval. I'll explain the rest of this code in a moment. So curval, that's current value. Notice that we are decreasing the current value by 5%. So I'm saying the current value equals itself times 0.95. So that's the same thing as decreasing the value by 5%. And then I'm going to talk about this other code in a moment. And then essentially we are setting this current value to be smaller and smaller and smaller. It's shrinking at every iteration inside this loop. It gets smaller. Now the thing is, maybe I don't know a priori, I don't know beforehand how many iterations it's going to take before the current value gets to be smaller than 1. So it starts off at 100. How long does it take before it gets to be smaller than 1? I don't know a priori, and maybe it's not possible to know because maybe the amount by which this is shrinking is not an exact or not the same number every time. Maybe this is some random number. Maybe the amount that this decreases by depends on some other data point or some other values. So I'm just going to say instead that whenever this current value gets to be smaller than 1, then we flip the toggle. We set the toggle to be false, and that ends the while statement. So this illustrates one of the reasons why you would prefer, the situation where you would prefer a while loop over a for loop. And that is when you don't know exactly how many iterations you are going to need. So then a while loop is generally preferred. You just have to be really careful to make sure that you are adding, towards the end of the while loop, you're adding something that will flip the toggle here. Okay, so I'm going to run all the code in this cell, and we can see that we get this series of messages. So the value equals, let's see, so it starts here. The value equals 95, and it's a 5% change from the original value. And then we eventually get all the way down. Here the current value is less than 1, of course. That was what we specified. And it is a 99.01% change from the original value. Okay, now I don't even know how many iterations it took. In fact, we don't have a counter in here to tell us how many total iterations there were. And maybe we don't care. Maybe it doesn't matter how many iterations happened. This is frequently the case for optimization problems. Okay, so I hope that is clear. I hope that makes sense. What I'd like to do now is just take a moment to explain a few additional things that you see in this code. So here I have this function deal, and I'm inputting the number 100. And the output of the deal function is these two variables here, curval and initval, so current value and initial value. Now what this deal function does is take the input and deals it out, so it distributes it equally to however many outputs you specify. So we can have additional ones. I'm going to have another variable called A and B and C and D and E and so on. And this is just to illustrate to you that I'm now defining or assigning the value of 100, because that's the input into the deal function, to all of these variables at the same time. So if you want to set a bunch of different variables to be equal to the same value, then this is the way to do that. You can use the deal function. And then let's see, so this line computes the percent change. So I'm using the formula for percent change. It's the initial value, which is never changed, so it's always set to be 100, minus the current value divided by the initial value, and then times 100. Here, this is a pretty neat function or approach. What I want to show you here is rounding to 2 decimal points. There's actually 2 ways that we can round to a certain number of decimal points. So if I just say round percent change, let me actually change this. So I'm going to write end parenthesis here, and then comment out the rest of this line. So I'm just rounding. This is going to round to the nearest integer here. And then I'm going to run this code again, but I'm going to add CLC to clear the command window so we don't get confused with all this other text from previous runs. Okay, so what you see now is that the percent change is, I guess, up here. This is fine. It's 5, 10, 14, 19. But you get down here and it just says 99% all the time. So there's not really enough precision. So what I want to do is not round this. So, if I just delete the round function and run this again, then we get a more accurate answer, but maybe 4 decimal points is a little bit too much precision. Maybe this is just more confusing. Let's say we just want to do a couple of degrees of precision here. All right, so here is what I see how I'm solving this problem. So I say round, but then I'm multiplying this number by 100. So this becomes 9,901 point, whatever else. And then I round that number. So that ends up being 99,001. And we know that that's 100 too high. That's 2 decimal points too large because I multiplied it by 100. So then I divide that result by 100. And then we get 99.01. So that is rounding to the nearest 01, the nearest hundredth. Now it turns out that actually there's an optional second input into the round function. And that specifies the number of points after the decimal point. So here we get basically the same result, this way or this way. So in this video, I introduced you to while loops. I showed you how to create a while loop. I introduced you to the concept of a toggle and how to use it. And I also talked about when to prefer a while loop versus a for loop. And just as a quick reminder, you should prefer a for loop when you know in advance how many iterations you're going to need. And you should prefer a while loop when you don't know in advance exactly how many iterations you will need to solve the problem.